Alright, we're going to take a look at the ratio test to see when a series converges. So first one we're going to take a look at is the sum as n equals 0 this time to infinity of 2 to the n over n factorial. Alright, so our ratio test says that we need to compare with the limit as n approaches infinity of a sub n plus 1, so the next term in line over a sub n and its absolute value, so negatives don't matter, and we need to see if that's less than 1 or greater than 1 or equal to 1, and that will tell us something about this series. So first I have to plug in n plus 1 into everything, so it'll be 2 to the n plus 1 over n plus 1 factorial. I'm taking the limit as n approaches infinity. Now I need to divide that, make a ratio, divide that by a sub n. I don't want to make a huge fraction, that would be a little cumbersome. So instead I'm going to write this almost like an elementary school student and divide that by a sub n, which is just 2 to the n over n factorial. It's the same thing as what the ratio test is telling us to look at. So, alright, I'm going to drop the limit part and just do some algebra here, so I'm not going to use an equal sign. So that is 2 to the n plus 1. Won't change the factorial part, but I am going to change this into a multiplication problem, so I have to take the reciprocal of the other side, n factorial right there, and 2 to the n. Alright, now we can do a little bit of fancy legwork here to get rid of some things. First, let's take a look at these two. You've got 2 to the n plus 1 and 2 to the n. We can cancel something out to kind of show you what that might be. Like, say that one's 2 to the 5th. This one would be 2 to the 4th. So 4 2's on the bottom, 5 2's on the top. You would cancel out everything there and you'd be left with 1 2 up top. Well, the same thing is going to happen here. We've got n 2's on the bottom and n plus 1 on the top. We're going to cancel it out and there's going to be 1 2 left over in the top. Now the factorial, something similar is going to happen there. So to think of a factorial, you've got 6 times 5 times 4 times 3 times 2 times 1. For n plus 1, for n it would just be 5 times 4 times 3 times 2. This would all cancel out with this. You're just left with the first number. In this case it won't be a 6, it's going to be an n. So this will cancel out with all of that on the bottom. You're simply left with an n. I believe that took care of everything. That canceled out. So I'm going to go back to my limit now, because we don't want to actually forget to do the limit. The limit as n approaches infinity of 2 over n, that equals 0. And so the ratio test tells us that if we are equal to 0, which is less than 1, that this series must converge. So this series here converges. Done. Alright, let's do one more. We'll do the second example here. Only 5 minutes in. Just take another minute or two. Alright, so the second example, let's do the one that looks harder. the sum from n equals 0 to infinity of n squared times 2 to the n plus 1 over 3 to the n. Alright, so again, to do this, we're going to compare a to n plus 1 over a to the n, and we're going to take the limit as n is approaching infinity, and it won't matter in this case, I don't think, but negatives don't matter. It's the absolute value. Move up a little bit there. So I don't even care about that, do I? Alright. Let's use blue here. So we need to plug in n plus 1. So we're going to have n plus 1 squared times 2. Let's see, it's already 2 to the n plus 1, so if we put in n plus 1, we'll have n plus 2 over 3 to the n plus 1. Alright, we're going to divide that by n squared times 2 to the n plus 1 over 3 to the n. Of course, we're going to turn that into multiplication. So let's do that here. So we have n plus 1 squared times 2 to the n plus 2 over 3 to the n plus 1. And we're turning the second one into multiplication by taking the reciprocal, 3 to the n over n squared times 2 to the n plus 1. And hopefully a lot of this starts to cancel out here. Let's see, the first thing I'm recognizing is this right here and this right here. We'll do something similar to the problem we had last time. That is just going to give us n plus 1 squared and n squared. Actually, can we do anything with that right now? Let's hold off on that one. I think this one is going to be easier for us. Oh, that was not a highlighter. Awesome. The 3n plus 1 to 3 to n will be nice and easy to deal with. That will just be a 3 is going to be left over. Down there on the bottom. And the next, the 2 to the n plus 1 and the 2 to the n plus 2, those are just off by 1 power. So there's going to be a 2 left over up top. And I don't know if we can necessarily do anything right quick with the other one. No. So let's leave that one be. We've got 2 times n plus 1 squared over, what do we have left on the bottom? We had a 3 and a n squared. So remember, we are taking the limit as n approaches infinity of this expression. And so to do that, you need to use L'Hopital's rule, which means you take the derivative of the top and the derivative of the bottom. So that will be 4 times n plus 1 times the derivative of the inside, which is just 1, so I need to write it. On the bottom, you've got 6n. And then you can take the derivative one more time. So on the top, you'll simply get 4. And on the bottom, you'll simply get 6, which is equal to 2/3. And our answer there, 2/3, is definitely less than 1, so this one also converges. Alright, hopefully that makes some sense.